morning to everyone. Now it's time to welcome our chief guest. It is with great pleasure that I extend a warm welcome to all of you as we come together for the second day of our faculty development program titled IoT in Healthcare. We are truly delighted to have each one of you with us. Today, we are honored to have with us an esteemed expert in the field, Mr. R.P. Karthik. Mr. Karthik is a distinguished professor in the Department of Electronics and Communication Engineering. He holds a Bachelor of Engineering degree in Electronics and Communication Engineering, a Master's degree in Embedded Systems, and is pursuing his PhD. His areas of specialization are truly impressive, encompassing embedded Internet of Things, biomedical instrumentation, industrial automation, and artificial intelligence. He has published various papers in international journals and presented various papers at international conferences, reflecting his deep commitment to advancing research and knowledge in his field. Expertise in the intersection of IoT and healthcare makes him the perfect speaker to guide us through today's session. His extensive knowledge and experience not only inspires us but also provides valuable guidance as we navigate the ever-evolving landscape of technology and security. As we move forward with today's program, I encourage everyone to take full advantage of the opportunity to engage with Mr. R.P. Karthik, observe his insights, and actively participate in the discussions. Once again, welcome you all and a heartfelt thank you to Mr. R.P. Karthik for joining us. We anticipate a day full of enlightenment and enrichment. Thank you. As we move forward with today's program, I encourage everyone to take full advantage of the opportunity to engage with Mr. R.P. Karthik. Sir, you can take over the session, sir.
Yeah, okay. Share my screen.
Sir, you can take over the session, sir.
Yeah, okay. Share my screen.
You can take over the session, sir.
Yeah, okay. Share my Hope my screen is visible. I'm audible, right?
Yes, sir.
Yeah, thank you. So today we are going to discuss about IoT in healthcare industry. So we start with an introduction to IoT and how the IoT architecture is formed, how that IoT architecture helps to frame an healthcare related IoT product. So we start with an IoT introduction. Yeah. All of you know about IoT. So it's a 2D system. So you already clearly know about deep learning and its basic technology. How the IoT architecture is an output technology. How the IoT gather the data required for a process related IoT related technology. So we start with even if it is IoT or even if it is a deep learning or machine learning or artificial intelligence. Data is a major so based on that data only, we can able to build a model. We can able to deploy that model into a hardware. Based on that only, we can able to design and develop a product. So for obtaining a data, the collection process is very important. In order to collect the data, so we are using a technology is called Internet of Things. It's a bit age-old technology. Now it's evolved into the another era called integrated Internet of Things or industrial integrated IoT. So different terms are there, but the basic main thing it's called as a IoT. So means it's a network of physical objects connected to the internet, which is shares the data and collects the data, and based on that data we can take an actions. So that's nothing but we called as the knowledge or outcome of the data. For collecting the data, in a biomedical industry or biomedical field, we want to have few points in a very important place. So we want to consider few things. So we will discuss about biomedical based device and design consideration in the upcoming slides. The number one, so if you want to design a IoT based device, we want to follow few characteristics. We want to tick all those things. Then only we want to design an IoT related product. The first number one is that IoT device must be a dynamic and self-adapting, which means the IoT device must to adapt all the environment. Say example, if you are designed and wearable gadgets for in order to monitor a patient heartbeat or SpO2, so that device must adapt all the environment, which means say example, the device must work globally, independent of the temperature, independent of the person, independent of the age, independent of the group of people. It want to adapt to the environment and nature. In the IoT characteristic, we define it as a uh, integration to the existing network. Say example, it's a Wi-Fi or Bluetooth. So that kind of points are known as the dynamic and self-adapting to the nature. Then second one is a self-configuring. So again, that's also very important perspective with respect to the networking. So these 2 points are also called as the infrastructure networking ability of an IoT device. So say example, now we are having a mobile phone. Now I can able to put my device in a hotspot, or I can able to access another hotspot. I can turn on my mobile as a public hotspot also. These kind of dynamic nature of property is also known as the infrastructure in network, and it must support all the interoperable communication protocols. As like in our mobile phone, we are have a 2G, 3G, 4G, 5G. IoT device is also having a different protocols. So that device must support the standard protocols. Say example, we have a 6 low PWWAN. So it's another protocol which is used for battery powered low power consuming device protocol. So while consuming a lower power, it want to operate on particular periods of time. So protocol also want to support this feature, and controller also want to support this feature. So then only it will be useful for designing an IoT related products. Then fourth and very important one is unique identity. So as like our mobile phone numbers are unique, the device also want to have an unique identity, and it also have a mechanism to store that unique identity number, that's called URI. So nowadays we are using IPv4. Now the networks are evolving with the IPv6. So trillions of devices we can able to connect together. Your IoT device must to have that IPv6 capable. Then it must integrate with any kind of information network, which means so my device want to connect to AWS, means that also want to connect with AWS, or Azure means Azure also want to connect it. So this is a real world OIC layer point. So mostly our focus for collecting the data, it's started with physical and data link layer. It's ended with an application layer. So in the physical layer, we are having a Wi-Fi, Bluetooth, Zigbee, LoRa. Many protocols are there. It's all come under the group of 802.11 category. It also have a dedicated frequencies, such as our Wi-Fi and Bluetooth shares 2.4 and 4.8 gigahertz of frequencies. Yeah, this is a very important protocols which is followed on IoT design aspects. Yeah, so it's a network of things. I already mentioned we are mostly going to work on the ground layer. It's called a physical layer. Physical layer is having a many different ways of building a communication. So that starts with basically we are having a QR code in Aadhaar. So whenever I can scan that QR code, it's get connected to the Aadhaar database, or it lists some few data which is relevant to my other data. So similarly, say example, if I am building a patient profile, I want to give a QR, or otherwise I have to give a NFC, or otherwise I can go with a beacons. Beacon also very similar to RFID tags. Then Bluetooth, Zigbee, multiple protocols are there. Most widely used today's industry is Bluetooth. It's a very low power consuming. So if we are using a Bluetooth version 5.2, then next one is a 6 LOW PAN. So low power, wide area personal networking protocol. It is used in battery powered IoT enabled device. Then about Wi-Fi. So these things are we know. So if you want to have a higher data rate, then we are gone with the 4G, 5G, or 3G or and Wi-Fi. Otherwise, for wireless wearable gadgets, we are gone with Bluetooth and 6 low WPAN, or otherwise, if you are going to send an hourly data or 15 minutes data or 10 minutes data only, the new protocol is called 4G. For in the 4G network also, it's called the concept is called an NB So NB-IoT, the dedicated SIMs also there. Hope that Geo is also part of that. They are giving a dedicated NB-IoT based SIM cards. It is to provide a basic internet connection with your device to your dedicated server. The server may be your AWS or Azure, whatever the server you are having. Then about the access layer. So access layer is an for a low power consumption. So this HTML, JSON we can leave as it is. So these are all used for high power consuming device. So JSON, MQTT, COAP, REST, and basic HTTP. So these four, and then web proxy. This is also very important protocol, which is used to pack the data from a lower end device, which formulates the data which is suitable for our higher end application layer. Say they want to be monitored by their doctor by using an computers. So user device is different. That doctor's device is different. I want to pull that data and push that data to one from a doctor device and from the device. So in order to pack that lower end device to higher end device data, I want to have a high performance AP which must have a lower power consumption. So this JSON, MQTT, COAP, REST, these 4 5 APIs are very important for accessing the data on the lower end of the network. Then about second layer. So second layer is another thing which is helpful for linking data between the lower end device to the my cloud server. So for that case, yes, someone is raised the hand. Any doubts? Okay. So in order to bring the data to the next layer, we want to have an intermediate servers. So we have different servers. That server have different authentication mechanism. That servers have a different encryption mechanism. Today we will discuss about the JSON REST API handling, AP token encryption, OAuth key, how to build that device. So we will see in the detailed manner. So TLS is also one of the options, but which required a more computational power. It's also part of we know about HTTPS. So in order to bring that HTTPS secured hypertext transport protocol layer, I need to have encryption from that my transport layer. So that's also part of IoT device design. So the mostly these two share and find layer are combined for our model. So we'll discuss about these layers in the upcoming session. Then about we'll have an application layer server. For an example, today we are going to discuss about ThinkSpeak and ThinkerCAD. We'll have another platform Arduino. Or otherwise you can build your own web application using your own web device, say such as we'll have a Fitbit app or another health monitoring apps or custom-based devices. Few healthcare devices they are provide a health tracking apps. So these are all like custom-built apps. So mostly in an end, if you want to design a IoT-related healthcare product, we want to focus on the end device power consumption and the device capability. These two layers only we want to focus. The top of these three layers will be developed and deployed on a end server. So in order to build that connection, establish that connection between a user device to the server, today we are following four major types. So one is request response. So in this state, it consumes a very lower power. It's for an unique, it build a unique connection between client and server. Once connection is closed after that, then most formally we are using exclusive uh, pair or full duplex mode of communication. This is very useful for handling secured patient data between an device and an client. Sir, say example, if I want to push a notification to the device, a number of device, then I want to go with a publicly subscribed model in a communication network. So this will be taken care by the UI building engineer. So yeah, so far we have discussed about few parameters which need to be considered for designing an IoT based device. So this is an generic architecture of an any IoT hardware device. So we know that IoT is brings our device to internet. So basically this may be a user device. So user want to connect with an internet. The end device is also want to connect with the internet through that 2G, 3G or 4G or Ethernet, anything, or otherwise it's have a wired network or wireless network. So it must have a IPv6 connection. So we might that device must support all the encryption facilities. So Wi-Fi, Bluetooth, we already discussed. Then the very important thing, say example, even though we can able to build a IoT enabled device, the major problem occurs on the selection of peripheral hardware. So how that sensors are calibrated, how it get integrate, or how it learns the data, or how it uses the data during the quantization. Say example, if I read a 1.229, so my embedded, if that engineer is rounded that data, so 2.229, it will be rounded on 1.2. So that 29 is get omitted. So sometimes that 0.29 data is also very important. So that engineer um, designer, the hardware designer must to taking care this data. Yeah. So then about we have different types of uh, domains are there in the IoT. So we are still focused towards only the telemedicine and healthcare. So yeah. So in that IoT level, so while designing the device, we have 6 levels of IoT devices. So the first one, say example, today mostly we are wearing an smartwatch. So that smartwatch we don't have any cloud storage option. Say example, today's heartbeat or SpO2 or temperature or another vital parameters I can able to monitor on local device. So that's called a level one. So if that watch come up with an data storage app, then it's called as an level two. So now I have a cloud storage. That Fitbit based devices or other today's in market we have an diabetic measurement devices, they will have a cloud analysis. So these cloud analysis helpful to find or predict the happenings in the so far in the future. So then about level four. So the mostly IoT based healthcare devices are end up with an level four. So we have an external observer or doctors or nurse or caretakers or sons and daughters of an elder people. So external observer, it will ended up to there. If you want to design a hospital based patient monitoring system. Then we'll have an coordinator and control node. It collects the data, process the data on the end, and it process the data to the cloud server. And there also they again the cloud analytics and external observers are there. So mostly, if you are want to design a variable based individual person health monitoring device, it's ended with level 4. So in order to design an embedded based controller, first of all we want to know about that microcontroller or microprocessor. So all the data in the real time is known as the analog data. So in our mobile phone or our text message, we are using data as a digital. So, if you want to measure that human body parameters such as heartbeat or temperature, all the data in the nature which is available in the analog. So, while selecting an controller, that device must to have an must to have a analog to digital conversion ability, and it must to have a higher crystal oscillator frequency. Say example, if I want to measure that EEG signal, so that ranges from alpha, beta, gamma, theta. So that started with 1 hertz to 50 hertz. So after that, I'm having some spectacle noise or some other induced noises. So in order to eliminate that, in order to recognize that fast data capturing ability, I want to have more operating speed on my micro controller or microprocessor. Then about ADC. So ADC again, it's an very important thing. It converts analog to digital data. We will discuss on the upcoming slide. So selection of ADC is also very important thing for designing an IoT based device. Will let us know. RAM and ROM are always required minimum 100 KB and beyond that. Then about the processor architecture, again it starts from 8-bit, 16-bit up to 32-bit based embedded controllers are there. Then in an Raspberry Pi, it's also coupled with a 64-bit processor, but it does not have an feature called onboard ADC. It have a plenty of RAM and ROM, but this does not have a dedicated ADC. So dedicated ADC is very important. So we have discussed a number of parameters. The very important thing, it must to connect with an internet. It must to have an so it must have a connecting ability to connect with the internet. It must have an security encryption. It must have IPv6. It must have a proper RAM, ROM. It must have ADC. So in the screen, I'm showing many different boards. So this is basic Arduino. Hope everybody is already have seen this board. So this is first version of a Node MCU. It starts with an basic Wi-Fi connection and only one analog channel. So now we'll have an ESP32 in the market. It have an up to 32-bit CPU, 12-bit ADC. So these are the basic boards. Does not have an Bluetooth. So these all the boards are having a Bluetooth, Wi-Fi. This is also have Zigbee, GPS. So many different types of Arduino boards are there. So why we have selected with Arduino means, so Arduino is very helpful for designing beginner level projects. So for an industry level projects also, now they are using ESP32 in their part of the product design. Yeah. So biomedical device design also have some different strategies. So I have taken this reference from this author book. You can refer if you want to follow. So for building a biomedical related device, we have a different scheme also. So there I have given a waterfall scheme. Apart from the different schemes are there. So first of all, we want to uh, think about our user in mind. What are the current devices they are using? What is the advantage and disadvantages of the current device or current design of the device? Then how we can add that value to the customer's new device. Say example, if I am designing a smartwatch, so I want to think all the parameters. Say example, whether that device is capable of having measuring a heartbeat, SpO2, or I can able to connect a GPS, or I can able to connect through phone call, how it performs, that battery life, how it's to the user. Say example, my targeted user group is above 55 or elder people. So then I want to take care about battery charging parameter, aesthetic, fitting, weight, user environment, and I want to analyze another competitive parameters also what to be considered on another hand. So apart from that, we will have a different regulatory bodies. Depends on the country. So US mean will have a FDA. Europe mean will have a different agencies. So I want to take in. I want to take in consideration all the parameters before getting deep dive into a biomedical based product design. So based on country or who is the end user, I want to follow these things and try to have a different norms. So for time being, we'll move on to the next. So these are generic stages. For each and every stage, I want to validate and verify my result with a real-time subject. For that, I want to have a committee approval. That committee is named as a ethical committee. So what all the time, if you are going to work with then biomedical related products or projects, you want to have an ethical committee clearance before, because you are going to work with an real human subject, not an any simulation. So the challenges for fabricating that final device. So you can see that the class of devices are there. Whenever that classes goes higher, say example, if it is an non penetrated or non contact based device, that risk and market penetration is also low. But the say example, if I am designing a prosthetic arm, that risk is very high, and you will have to pause at different stages. So we'll have a different consultorium, we have a different organization, they have a different norms we want to follow and do it. So yeah, so that's all about design of uh, design of IoT based device. So we already know about that IoT device. It have a lower end architecture. So we want to mostly focus on sensor based selection and device based selection. Device based also we have discussed. It must have IPv6 and 64 or 32-bit operating system about ADC. So about sensors, sensor also have different varieties and parameters. Say example, if I want to measure that temperature. So temperature itself, we have different types of sensing device based on that resistance change, based on capacitance change, or based on light reflection, refraction, nanotechnology based devices or MEMS based devices. Different varieties of sensors are there with respect to the user working environment or devices intended working nature. I want to select it particularly. So today market, so if you want to have a prototype, will have a different type of sensor where temperature and humidity or moisture have an inter-direct relationship between two things. So say example, we have an DHT11 and DHT22. It brings humidity and temperature which is available in the room. Again, it's a different context. If you want to measure the temperature of human body at an instant, we'll have a IR based thermal sensors also there. If you want exact surface temperature, again we'll have a thermometers. So it's not in digital. Again, it's an analog. If you want to have a digital, then we'll have a silicon based devices are there. Similarly, we'll have a different type of yes, somebody's raised hand. uh, any clarification is needed okay. So while considering the selection of the sensor, we want to consider it want to work on the all the environment, electric and magnetic interference, and all the Horse environment. So these norms will be provided by that country, ISO or FDE or European Union standards. So while considering it, I want to first of all know about the sensor material and range of operation, accuracy it's provides. Say example, if the temperature is 35.002, if it gives a 34.8 or 35.2, it's an error. So I want to know that thing. So some cases, say example, if it is I am going to design a wearable watch, then it's acceptable. If I want to design exact equipment which is going to be worked on then intended environment such as in a hospital, then it's not accepted. Then about as a design engineer, you want to know about conservation of filters, sampling voltage, yeah, operating voltage and current consumption for battery oriented devices also very important while considering. Then EMI, EMF. It's based on that, say example, the DST11 I mentioned before, so that starts from 150 rupees. Say example, if I want to have an exact biomedical based measurement device, that's cost around 4,000, 3,000 at the end. Same, it gives the same data, but the accuracy and operating range, noise, it's are there. Then about the cost is also a very important thing. So then about the sensor selection, we have a different sensors are there which is used in medical application. We have a different thing. About that motion, velocity, displacement, and imaging. Imaging part will have a X-ray, CRI, MRI, CT, different things over there. So we can use magnetic based sensors or cameras. So camera also will have a multispectral the hyperspectral camera. So today market is focusing to build a device. IBM is focused to build a device for finding device a disease on your home. So it's a handheld device. You can predict more than 25 major devices. They are intended to launch the device by 2030. You can refer there. So that's a type of ADC converter. For now, we'll move on to the next. Yeah, take an example for an case study. If you want to design an ECG based system, I want to know the basic few parameters. Say example, our human body is also act as an electric generator. Our food act as a battery power. So it also generates an electrical pulse. So that starts from, say example, that minimal electrical impulse produced by a human body is an 10 microvolt. Say example, there it's called as, yeah, so 30 microwatts. So 100 microwatts. So different organs in our body induces a different kind of electrical impulses. So while measuring that electrical impulse, I can able to push that minimal voltage into a higher level voltage. For that, I want to have an instrumentation amplifier. So that instrumentation amplifier reach that very lower signal along with the noise. So in order to filter that noise, I want to have a notch filter or other signal oriented filter. Then only I want to pass the data to a analog to digital converter. So that analog to digital converter converts your data into the accurate form. So in real time voltage, that means real time signal into a quantified digital data. So note it haven't quantified, not an exact data. Then we want to have a software implementation top of that. Then we'll have a hardware implementation. Then the data push it to the cloud. Then you are taking an action. So these are a few boards which is available on a market for a ready to design. So then about so these devices are called as a microcontroller boards, or a few are called as a microprocessor, which is used to gather your real-time data. These boards are onboarded have an ADC module. So we'll have a Raspberry Pi 5 today in the market. So it supports higher data processing. So it supports higher data processing capability. It onboard it have a GPU graphical processing unit. Say example, previously we have discussed about a imaging system. Say I want to scan a X-ray or any other system. You want to have a higher complex processing system. So Raspberry Pi is used to process complex data. It's not mostly needed in a lower end data. Say example, if I want to process EG, I want to process an EG headband data, then I want to have up to 30 channels of EG data. So in order to process the 30 channel, our Arduino or ESP32 is not enough. If I want to apply any notch filtering or Gaussian filters or anything, you want to have a higher capable computers. Instead of computer, we can go with an Raspberry Pi. So in order to process higher um, uh, machine learning or deep learning or AI based algorithms on an edge computer or edge node. So this is not suitable for wearable computers, but it is suitable for I have discussed it 6 levels. The level 5 and 6 will have a coordinator node. So there we want to use an camera based device or any other thousands of devices data is aggregate and we want to process me. Then we want to go with this NVIDIA GPU cards. So that's named as the NVIDIA. They have named as a Jetson. So this is not suitable for wearable device, but it is suitable for processing and data. So higher points of data. So it's also again depends. Say example, if you are designing an controller or processor which is to be worked on medical industry, then you want to go select with this kind of processor. These are industry grade processor. Then for a beginner, if you want to start with an IoT product development, the commercial option which is easily readily available at the cost of 150 to 700 rupees, then we'll have an option called Node MCU and ESP32. For important note, both Node MCU and ESP32 have a ADC port. Node MCU have only one analog to digital conversion pin and yes, whether to have multiple pins in the range of 15, but in the 15 also I can able to use 6 to 8 only effectively if I have turned on Wi-Fi means. So meanwhile, it have a Bluetooth capability is with 32, and it have an I think it's a 12-bit ADC, 14 channel 12-bit ADC. 12-bit ADC means a higher resolution. 4096 samples I can able to perform in an iteration of single sampling interval. So this is a typical pin diagram of a node MCU. It have only one analog to digital conversion unit. So the another important thing while selection sensor, I mentioned, we want to think about that voltage range of that sensor. So this node MCU and ESP32 both works on 3.3 voltage, but the Arduino board works on 5 voltage. Then you will have a digital input 12. So one I have already mentioned. Then about the clock speed, it have excellent clock speed, 80 megahertz in the boosted mode. It runs on the 160 megahertz. RAM also it's a configurable. Its range starts from 4 megabytes to 32 megabytes. Power consumption, it consumes if you are put the device on the lower sleep mode or hyper sleep mode, then it consumes only 10 10 microamps. Then about that Arduino. For time being, we'll move on to the next topic. So the about the Arduino. So Arduino is an open sourced. So Arduino is an open source environment tool, so which is used to build a dedicated software. So I will give some glimpse of introduction about Arduino. Okay? Then we'll move on to the cloud platform for developing, deploying that Arduino boards and codes. So we want to configure Arduino software. We want to select that Arduino board. Different Arduino boards are there. So in order to load that Arduino board, we want to go tools and select that board, and we want to configure port. Then we want to write a code and compile that code. It is useful for Arduino. In order to add a ESP32 or ESP8266, which means Node MCU, I want to load this specific two URLs on my Arduino software. Arduino software available on Arduino.cc website. You can go and download. So there, I want to add to the additional board manager. Then I want to select a new board and I want to install Node MCU ESP32 and ESP32 software. It downloads and installs few bundle of software. Then I can able to select Node MCU tool. So there they can able to configure the flash memory size and operating frequency and communication rate. Then I want to select my port connected computer port which is connected. Yeah. Then about the things we, yeah, I have mentioned few web application. Yearly about IEEE, FTT. Then we'll have an different application. So as a beginner, if you want to connect, push the data to the cloud, then you want to retrieve it back and do some meaningful data analytics. Then you want to have some full-fledged cloud server. As a beginner, we cannot able to do it from a scratch. Then we'll have a platform called application as a service. We'll have, I hope you know about that SaaS, PaaS, and IaaS. So it's an application as a service. ThinkSpeak is an application. So that hardware part, the physical layer, data link layer, we want to compile with the help of the node MCU or ESP32 device. Then you want to push the data to the cloud. So in order to update that data, we are using here ThinkSpeak. It's a sponsored product developed by an once again. We want to install ThinkSpeak library. It's an regular procedure. We want to go Arduino library manager and include that library. Again, yeah. So now we enter into the coding part. So we have a digital input and output device. So sensors are we have two type of sensors. One is analog and another one is digital. So that if you want to have a variable data in nature, say example temperature is get varies in the nature, then it's gone with the analog. So say example if it is on and off, that status are known as digital input and outputs. So move on to the ThinkSpeak session for time being. So just a simple Arduino input output code. So in online we'll have a different interface. The basic thing we want to set which pin is the input or which pin is output, whether I want to read or whether I want to write. Another important parameters to be considered for all kind of microcontroller based projects. We want to know about each and individual pins power supply handling ability. Most of the beginner level we forgot to check that current consumption or current deliverables by the individual pin. Take an example, Arduino boards not goes beyond that 15 milliamps per particular pin. For your another note, if you are connecting regular LED 3 LEDs available on the market at 3.3 voltage, it consumes the regular LED only. I'm speaking. It consumes nearly 10 milliamps of current. So which means mo- at the worst case, I can able to connect only two LEDs simultaneously at a single pin using your node MCU boards. So PIC microcontroller, another Renesas-based controller, which supports up to maximum 40 milliamps of current on the particular pin. So if you turn on, it maximum capable of push up to 50 milliamps of current. So while selecting a sensor, I want to check what is the maximum operating current consumed by the device. So if it is beyond that 10 to 20 milliamps, you want to go with a separate, yeah, separated power supply or power driving module. So that's why only circuit gets complex while if it is commenting on an physical product. So simple Arduino project so based on LED. So we are going to develop the same on the Tinkercad platform now, and we will discuss about it on the later. So this is about analog to digital conversion. Again, it also have a different sampling rate, so that's also very important. Say example, we have earlier discussed about EEG waveforms. So say example, if I want to capture alpha or theta wave from a brain, it gets changed on every eye movements. Take example, the sample of the real-time signal is gets changed 20,000 times per second. Mean at least I want to sample 40,000 times per second. But in order to retrieve that excellent signal, if you want to retrieve an exact signal which is happened on the real time, at least 10 times or at least 5 times of sampling rate is required. Say example, this refer this diagram is a 10 hertz. It's an different thing. So that sampling 44 and sampling 192. So if I can capable of build a 192 hertz, the sine wave, exact sine wave, I can able to build through the digital response. So the 44 hertz of sampling, I can able to miss out most of the signal. So this is called quantization error. Then about analog output also needed. So for time being, we'll move on to the next. Yeah, these are really different type of sensors available in the market, which can be used on the biomedical application with respect to the demand of the applications. Yeah. So we discussed about the different cloud computing applications. So once we have designed the hardware, then data want to be pushed to the cloud. So in the cloud, I want to do an analytics part. Let's take an example. There we'll have three different type of services are available. One is IaaS, another one is the PaaS, which means infrastructure as a service, platform as a service, software as a service. For this case, we want to go with an SaaS. So PaaS and as IaaS is an difficult for a beginner. So we have taken ThinkSpeak as a or says other open source platforms also available. For example, IBM Watson is also. So all of you can able to do this thing in your mobile phone or laptop. For time being, I will show how to build channel, how it's get updated on the cloud. So nothing, you will need to have only one email ID. So that maybe if it is your academic email ID, then it's good for you to process some advanced data analytics. Free of tools are available, otherwise Gmail is enough. So you want to such things speak and get login with that. Then you want to build a whenever you log in, you can able to see this channel tab. So there you want to click the new channel. So initially you have built, say now I have considered already we have built your hardware device. So that hardware device is capable of connect to the internet. So now I want to build a data reception point on the cloud. So for that I put that channel. So that channel have my API key, security, token, authenticator, everything it have. So everything will be managed by my ThinkSpeak server. So new channel. So I want to give a channel name and I want to give a channel ID. So I want to select that field data. So how much number of sensor data I'm going to transfer, whether four variables or five variables. Take an example, if I have a temperature and humidity, this is two field of data. Take an example, if I have a SpO2 heart rate, this is another two field of data. So totally, I'm having four different data. So otherwise, I want to have a geolocation of the patient movements or battery remaining battery life of the patient. So that's also called as another field of data. So totally, in that free edition, we can build up to uh, 8 fields. So once you build with the channel setting, then I want to move to the sharing option. So I sample I have given. So you will get a channel ID, then author name, and you want to change it to the public. This is a very important thing. So then only you can able to read and write on the internet. Once again, sorry for the inconvenience. So we want to share the channel with the everyone. Else you can go with the private or users based email ID. It is used to authenticate that data. So if you change the everyone, you can see the channel data on the public internet without username and password. Also, user can able to see that. So I have discussed about security and the APIs, keys, tokening, everything. So there, then the next step I want to move with the then AP key base. There you will give two keys. One is for read key, another one is for write key, which enables read and write your data to and from the cloud. So we have a test field. Uh, the test field will have a different. This is an API testing method, which is to test whether my channel is works, whether my feeds are get updated. We also discussed the data handling format called JSON. So initially I have mentioned that. So it's low power device. We can use JSON. So another different types of data packing mechanisms also there, but the JSON is recommended for a low power devices, low power, low processing capability of devices. So now today's computers also they are following JSON data framework format. So now we I have considered I have designed a node MCU with help of LEDs or other sensor. It is connected through Wi-Fi to my internet. So internet means it's a things big. Just I'm using my mouse pad for writing this text, not having uh, touch pin. So it's look like that. Okay, so I through Wi-Fi I want to connect to the internet. From internet it goes to ThinkSpeak. ThinkSpeak again connected with your end computer or your end computer to cloud. Also you can push from cloud to in device. Also you can push. So now that ThinkSpeak acts as a connecting platform which bridges the data from a user to the end. So ThinkSpeak APIs will check it at the last few minutes. Okay, by doing this ThinkSpeak app, I can able to add also a visualization field. Then I can able to see my signal strength, or I can able to see my data, or I can post that data to the my public websites. So another important thing why I have selected ThinkSpeak mean ThinkSpeak is linked with a MATLAB. If you have a academic MATLAB license or MATLAB key, then you can able to do an data analytics on the server. So let's take an example. The yesterday you have discussed about deep learning, machine learning algorithms and methodologies. So we'll have a different supervised learning or unsupervised learning or other neural networks based learnings. So that MATLAB also supports, about if you are aware of MATLAB, MATLAB is also supports excellent bundle of tools for processing your data. So in this use case, the ThinkSpeak is sponsored by MATLAB. It's a part of MATLAB product. So once data are reached ThinkSpeak server, then you can process that data on the cloud itself. I can able to find that correlation. I can able to find a relation between the variable data. So I took some random data, so that's why it looks like there. I put and that data between that during that signal transmission and during that ideal stage of signal of the user while I were designed some small wearable gadgets and we have tested. So we can able to do some meaningful uh, analysis in the cloud. So that's why we moved with an ThinkSpeak. So then we'll see that real time demonstration. Take an example. So if you go with an thingspeak.com channel public, so I have earlier mentioned, so if you go with public, you will have a different types of channels which is publicly available. Take an example. Now I have taken another weather station and another wind power station. So there we can able to see different data graphs and different plots. Different plots. You can see you will have a field of data. So all the data is given some different information. So I can able to tag my geolocation there. So it's a live weather data report. You can see it's a 17th August 12 45. So there it's in GMT plus 5.5. So it's 12:45. They are so wind speed, humidity, temperature, rainfall, air pressure, light intensity and power level. Now, based on this, you can see you will have a humidity and temperature have a direct correlation. So then we'll have a MATLAB analysis and MATLAB visualization. For this, you want to log in with your account, then you can able to work on this. So this is public domain data, so it cannot permit me to analysis that open data. You can also select different uh, graph format. So we'll see how to build it in a real time. Means we will see in coming um, discussion. Okay, we can able to see different types of graphs and different type of analytical part. Apart from hardware, whenever you push the data to that cloud, in that cloud also you can do a lot of magics. Okay, then about our project. So just you want to do a regular login. So just you can in internet you can give a thing speak. Then you want to log in with your email ID and it asks the password, or you can build your own. So the first step we get goes with an home page. Okay, then second, it's logged out. Yeah, so channel, my channel. So I already built a channel for this session. One second. So if now if I enter into this, then I can do a MATLAB visualization just for an just I go with only histogram. Just I want to run only that default MATLAB code for the test. So meanwhile we'll go with an with MATLAB. I thought that the server is too low. Then I want to go with my original channel. Yeah, so there you want to click that new channel and you want to enter name, description, multiple field you want. You have to name it and you finally you want to save it. So I have already have a channel for a test. Okay, so I already built a channel. So there channel setting you want to change all these things. So channel ID is default one. It's built. It's a unique one. So temperature, humidity, IR, right, the vibration. So you can give whatever the name you want. You can give. Otherwise, the data is default field one, field two, multiple data. If you want, you can give. Then about sharing, you want to change it into the public everyone, then only it can be visible. Then about the API keys, this is for reading, this is for writing. So I have given that API key testing. For testing, we'll have a Postman. I have uninstalled. Okay. So we have a Postman tool. By using that, I can able to select my data. So it's a right channel feed. So you can see in both private and public. The channel zero data is last written on March 22. Now I move to incognito window. So now I want to set data to a random value. Yeah, it's a fifth value is inserted. Yeah, now you can see that new data is inserted. So I can able to write data to the particular field. So similarly, we'll have an read API key. So in the read, if I want to get that particular field, so last time I have written on field one. Field one. Let's try one. Okay, so this is a JSON format data. So it's I have inserted 12 on the fifth entry, right? So there I have 12. So it's on fifth entry. The AP it also brings. So this is a JSON format data. You can see. So the 12 the date and time. The last entry will be fetched. Yeah. Then what the data is generated for time being will run the data. Yeah, so it's plotted histogram data. So meanwhile, if you want to change the data with respect to your MATLAB code, you can change and do it. So this is the advantage of gone with the things quick. Then if you want to do anything, you can change. Okay, you can explore your own. So this is all about ThinkSpeak. Then another platform is called ThinkerCAD. You can build your own. Again, that's also required an academic license, educator license. This is also free. You can so I will remove all this thing. Okay, so this is the first initial interface. I want to take an Arduino boards that we already discussed. Then we'll have an say example. I want to turn on LED. So in order to connect that LED, I want to have resistors to be connected. So default for time being, I taken the default LED which is connected on board. So now my wires are connected. So this is simulation. So similarly, it is available for ESP32 non-MCU. Some simulators are there. Without real hardware, also you can simulate and get the data. Take an example. Now my hardware part is done. Then next I want to go with the code. So this is default code. I have taken LED resistors. So that LED is connected on the 13th pin. So 13th pin and default LED. So there it's called a L. So L is a default LED. L is connected with the 13th pin. So for time being, so I have using that default LED. So seconds I have changed one to turn on and turn off LED and every 300 milliseconds for quick flashing of that LED. Okay. Then I want to compile it. Yeah, now you can see that it is black. The LED is blinking on every 300 milliseconds, turn on and turn off. Similarly, you can do it's an easy way of coding and testing our initial sketches. So different platforms are there. You can able to build a mobile application using Blink app. Yeah, also, you will have a Arduino cloud. So from the Arduino cloud, you can directly build the code and deploy the code to a node MCU. You can compile the code for an ESP32. Arduino cloud is also another mm, easy way of building application without a physical board. You can code and test it on the cloud. But for beginners, it's very useful. But in this Thinkercad, you can able to build a both CAD model. You can both build a circuit PCB. You can able to simulate all those things. All in one platform means it's something that CAD is good for a beginner's stage. Uh, Hope I have given my session up to your now with session move to query session. Meanwhile, if you have any doubts or any questions, we can discuss about it. Ma'am, am I audible? Ma'am, am I audible? Yeah, thank you. Yeah, thank you, thank you. If you have any queries, you can unmute your mic, or otherwise you can do a text. I already worked with few industry-based IoT products also. If you want to build a low-power device, then you can go with the Bluetooth 5.2 or 5.3 stack. ESP32 and ESP8266 does not have an stable ADC. So it have a problem with that ADC in the data. Low power device, then you can go with the Bluetooth stable 1.2 so or we want to add some stabilization circuits in order to from a ESP32 and ESP32 and so with ESP32 it have onboard does not have an stable ADC. Bluetooth so and Wi-Fi. So, yeah, it's a question of how to implement any device into our research. First of all, we want to select what kind of operation we are going to do. Take an simple example. We have discussed the same use case, EEG device. Each device we have up to 30 electrodes, 10, 20, 10, 30, 20, 30 electrode schemas are there. Take an example. I want to process only, I want to identify my eyeball movement. Then I have only reference electrode and two electrodes to be placed on left and right eyebrows. So only three channels. So that three channel data can be processed with the help of node MCU, sorry, ESP32 itself. If you want to go beyond that, if you want to process that noise cancellation, then you want to add manual circuit or algorithm, or otherwise go with an Raspberry Pi Zero. If you want to go with 30 electrode system, then you can go with the Raspberry Pi 4 or 5. Easy code ways are there. Now AIs are gives a more user-friendly codes. Anyhow, that code is not 100% work on the end environment, but it's also okay to work with that code. If you know that basics, then you can do. So for a beginner, you can start with an Arduino Uno or ESP32. It's a good way of starting your exploration. So basically, hardware is used to uh, gather the data. So this way you want to implement it. First of all, you want to select what project you want to do, what kind of data you are going to read. There any simulation chip for AI and IoT? Yes, the Tinkercad you can do Arduino IoT cloud platform is there. I have it. So Arduino IoT platform is the best tool. Uh, is- there you can build and deploy your application. So this is the best free available tool in the market. Uh, skip for now. So there also you'll have a similar interface like coding, deploy a content from your cloud. Yeah, so I have built it on project. So it's also very similar one. You can push the data pop. It's also have the same set of routines. But the major thing, it build code for your needs. Take an example. Yeah, you can develop and deploy libraries there. You can do anything, but it have some limited number of calls. This does not provide a flexibility like your ThinkSpeak integrated with the MATLAB, so you can able to do a lot of analytics there. So that's why I preferred with an ThinkSpeak. If you want to do real commercial product, then there is no way to go with ThinkSpeak or IoT cloud. You can go with your own cloud. You want to start from a scratch, or otherwise just you want to gather the data and you want to analyze the data or basic thing only, then you can go with the obviously that open sourcely available tools. But both ThinkSpeak and Arduino Cloud, they offers us to download our data. The major disadvantage of both vendor, they do not provide backup option. If anything happened on server, uh, your data gone. You cannot able to recover it. Even Google also there. Google Firebase is there. You can also use it's for an IoT based application. They have some free tools. If you have an edu based email ID, then you can work with there also. Which means your institute must to opt that developer option in that particular use case. Otherwise, you can go with a normal Gmail ID. Any queries? So otherwise, no query. Then, ma'am, are you there, sir? If there are any more doubts or any clarification needed, you can connect through my email ID. I am sharing it. Or otherwise, you can connect with me through my phone number. Yeah, thank you all. Thank you, ma'am. Um, okay.
Participants are requested to ask if any queries. You can ask or post your queries in the chat box.
Already few members asked if they have clarified through the chat window. Anybody want to have more questions? Then you can.
The feedback link for the session is shared in the chat box. Everyone are requested to fill the form.
If someone is raised a hand. Soumya ma'am, any questions there? Sriram, any question? Any clarifications there? Yeah. I hope there is no question, so we'll end up the session.
As we conclude today's session, I extend our sincere thanks to Mr. R.P. Karthik for his invaluable insights on IoT in healthcare. Your expertise has been both enlightening and inspiring. A special thank you to the organizing team for the dedication in making this event successful. And to all our participants, your engagement has been truly appreciated. Thank you all for making today's session a great success. Have a wonderful day. Thank you, sir.
Thank you. Thank you, ma'am and sir.